Hello students, so let us start with the single electrode potential. What do you mean by single electrode potential? A single electrode potential means it's a tendency of a metal electrode to undergo oxidation or reduction when a metal electrode is dipped in its own solution. So it is observed that some of the electrode have a tendency to undergo oxidation, some of the electrode having a tendency to undergo reduction. So what is the natural tendency of a metal electrode when it is dipped in its own solution? That what mean by single electrode potential. So generally what is happening when a metal is dipped in its own solution, now a metal, you imagine metal have a tendency to undergo oxidation. If its oxidation means no electron will be released, so you will see an electrons around that particular electron, and solution, in the solution metal ions will be there. So there is a potential difference is developing between a metal and the solution that we are measuring as a single electrode potential. Okay, so that's the way you can define a single electrode potential, and the factors which are influencing the single electrode potential are definitely first one, the nature of metal. That means what is the metal. Depending on the metal, the electrode potential do varies, because different metals have different electrode potential. So it is observed that depending on metal, the metal electrode potential varies. Then the next point, the nature of electrolyte. Nature of electrolyte. The electrode potential value always depends on the kind of electrolyte that you take, because it's always not the same metal solution that we will take. If some other electrolyte takes means electrode potential do vary. So it depends. Electrode potential depends on the nature of electrolyte as well. Then the concentration of electrolyte, definitely concentration of electrolyte. Then finally temperature. These are the important factors which influence the standard reduction potential value, or now I will say the single electrode potential of a particular electrode. Now, some of the electrode have a tendency to undergo oxidation, some of the electrode having a tendency to reduction. So if you want to compare between two electrodes, it's always you have to fix one particular tendency. For example, according to UPSC, we comparing the reduction potential value. If a metal electrode having a tendency to undergo reduction, we just measuring the reduction potential value, and we measuring the reduction potential value of other electrode as well to have a comparison. So if a particular electrode having higher reduction potential value, they undergo reduction, and if a metal electrode having lower reduction potential value, that undergo oxidation. That's the way you can compare. Now having the value of a single electrode potential of a particular electrode, if they having higher reduction potential value, that's undergo reduction. Lower reduction potential value, they undergo oxidation. So that's the way we can able to compare. So according to IUPSC, the reduction potential value we taken as a standard one, and we comparing the reduction potential value of different electrode. That's the according to IUPSC convention, we considering the reduction potential value of different electrode. Now next point, how we can measure the reduction potential of a particular electrode, because we know one particular electrode do not constitute a cell. If you want a cell, minimum of 2 electrode is required. One has to act as an anode, one has to act as a cathode. So electron has to flow from anode to cathode, so that is required. So means single electrode potential we cannot measure easily. That why we need a reference electrode to come to have a cell. First of all, we want a cell, right? Then only we can measure the potential difference between the two electrodes. So what we are selecting, we selecting a reference electrode. We selected one of the important reference electrode is hydrogen electrode, so we choosing hydrogen electrode as the reference electrode. Now with respect to hydrogen electrode, we measuring the electrode potential of a of other electrodes, which means, for example, if you want to measure the electrode potential of zinc, what do you need to do? You choose zinc as one of the electrode and hydrogen electrode as other. So which when they're making a cell, we can measure the electrode potential of zinc, because we arbitrarily fixing the electrode potential of hydrogen as 0. That's the way we finding the electrode potential of other electrode. We fixed the electrode potential of hydrogen as 0, which means now you can measure the electrode potential of other electrode with respect to hydrogen electrode. That why we considering hydrogen electrode as a reference electrode, and we selecting hydrogen as our reference electrode. So let us understand what is hydrogen electrode is all about. Hydrogen electrode consists of a platinum wire which is now fixed to a platinum foil and which is dipped in a solution, that is HCl solution is filled here, and which is kept at 1 molar concentration of HCl. So now this is actually taken in an inverted glass tube. Inverted glass tube is there where hydrogen gas is bubbled through the solution. So now we are arbitrarily fixing the electrode potential of hydrogen. The standard electrode potential of hydrogen we are fixing as 0, which means now, with respect to this hydrogen electrode, we can measure the electrode potential of other. So, what's the point here? We consider this as a standard hydrogen electrode, SHE, or we will say normal hydrogen electrode. Because why we saying standard, because we fixing a standard condition. We always know we need standard values, so we cannot have measurement in different conditions. So we fixing the conditions, we fixing the pressure of if the electrode potential, if you want to measure the electrode potential of a particular electrode, then we fixing the pressure of the gas. If the gas is involved, pressure of the gas is fixed as 1 bar, and temperature we fixed as 298 Kelvin. Okay, temperature we fixed at 298 Kelvin, and the concentration of the electrolyte solution is always 1 molar. This is the way we measuring the electrode potential of a particular electrode. So we fixing this, we make sure we measuring the electrode potential in a standard condition. Standard condition means at a pressure of 1 bar pressure, temperature of 298 Kelvin, and concentration of the solution is fixed at 1 molar. By choosing this fixed values, we measuring the electrode potential of a particular electrode. So what we are now doing, one is our hydrogen electrode. With respect to hydrogen electrode, we finding the reduction potential of other. So how can we, let us check, because now we measuring the cell potential as E cell. Now we can say E0 cell, at the 0 means standard condition. E0 cell we always measure as E cathode minus E anode. This is the equation to find the potential difference between the two cells. We will call cell potential, that is, or EMF of the cell. EMF of the cell, that we are measuring as E cathode minus E anode. That is the standard electrode potential of cathode minus standard electrode potential of anode. So if hydrogen is a reference electrode, one value should be 0. We want to know whether it will act as an anode or a cathode, because always understand, if the reduction potential value is higher, then it will act as a cathode, and the reduction potential value is lower, then it will act as an anode. So if let us take two examples. In the case of zinc, it is observed that zinc have a more tendency to undergo oxidation with respect to hydrogen electrode, which means zinc is our anode and hydrogen will act as a cathode. So how can you measure the reduction potential of zinc? because now we measure the EMF, we getting EMF as 0.76. So we know zinc have a tendency to undergo oxidation. So E0 cathode is actually the reduction potential of hydrogen, because hydrogen will act as a cathode, minus E0 anode will be equal to 0.76. This is the EMF that we got. So we know this E0 cathode will be 0 because that is hydrogen acting as a cathode. So 0 minus E0 anode will be equal to 0.76, which means the reduction potential of zinc is equal to minus 0.76. That's the value we got for the standard reduction potential of zinc is actually minus 0.76. Now you imagine you taken a copper electrode. When we take in a copper electrode, it is observed that copper having a tendency to undergo reduction compared to hydrogen, which means this time hydrogen acting as an anode and copper acting as a cathode. So it is observed that the EMF of the cell is 0.34. Remember, EMF is always positive. The cell potential that we know we getting when we have a anode and cathode. So EMF of the cell always positive. So it's got 0.34, which means E0 cathode minus E0 anode will be equal to 0.34. Remember, this time our cathode is copper, so E0 copper minus E0 anode, that is our hydrogen, which is equal to 0.34, which means we can understand that the E0 value of copper will be equal to exactly equal to, sorry, it's 0.34. It is observed that the E0 value of copper 2 plus is 0.34. So that's the way we measuring the reduction potential of each electrode by comparing with respect to hydrogen. Remember, we fixed the reduction potential value of hydrogen as 0, so we can find the reduction potential of other by having a cell, and the EMF of the value actually suggests you the reduction potential of that particular electrode. If the reduction potential value is negative, reduction potential value can have negative, reduction potential value can have positive, reduction potential value of hydrogen we saw it is 0 as well. So that's the point you can remember. Reduction potential value negative means normally it have more tendency to undergo oxidation. With respect to hydrogen, it have a tendency to undergo oxidation, which means they should have negative reduction potential value. And if the reduction potential value is positive, means it have a tendency to undergo reduction. So with respect to hydrogen, it have a positive value. So always understand it's higher the reduction potential value. For example, 0.34 is the reduction potential of copper. We can understand silver having higher reduction potential value than copper. So if you construct a cell between copper and silver, you have to understand silver undergo reduction, copper undergo oxidation, because with respect to silver, copper having less tendency to undergo reduction and silver having more tendency to undergo oxidation. So if you have a cell between copper and silver undergo reduction, copper undergo oxidation. So that's the way you can compare by having a reduction potential value. So how can you represent a cell? Now, if you construct a cell between zinc and hydrogen, we know zinc having a tendency to undergo oxidation. So Zn bar, Zn2 plus. Now this is separated by, remember the concentration. We always considering 1 molar solution. So Zn2 plus aqueous 1 molar. So we have a double bar, which suggests it's a salt bridge. Then remember, when you represent the cell, you have to make sure that's anode reaction, cathode reaction we are directly writing. So here by looking at this, we can understand zinc undergo Zn2 plus, zinc undergo oxidation. So while we writing the reduction, you have to make sure H plus is written first, because H plus is converted into hydrogen. So H plus 1 molar and aqueous, right? So we can write it will be 1 molar and aqueous. This is actually converted into hydrogen. Hydrogen, that is gas, uh, 1 bar pressure. No, you have to make, you already know it's always measured in the 1 bar pressure, and flat vertical line is not required. Then remember, hydrogen is a gas, right? So such electrode you require a inert electrode like platinum to have that electrode. So this is the way you can represent the how you measure the EMF of this particular cell, where zinc undergo oxidation, hydrogen undergo reduction. So with respect to hydrogen electrode, you can measure the electrode potential of a zinc. Now, what will be the change if you ask you to represent the cell between copper and hydrogen? The change will be here. Hydrogen is acting as oxidation, so you can write hydrogen first. Before that, now platinum is our inert electrode. Hydrogen, which is now maintained at, which is a gas, which is maintained at 1 bar pressure, and H plus aqueous, 1 molar concentration, and which is separated by a double vertical line, which suggests that it is a salt bridge. And this time copper is undergo oxidation, so copper 2 plus aqueous. 1 molar concentration bar Cu, which is again copper in the solid form, and that's all. So that's the point. Remember what's the change here? Here remember, with respect to zinc, hydrogen undergo reduction. With respect to copper, hydrogen undergo oxidation. So here hydrogen is our anode, copper is our cathode. Here zinc is our anode, hydrogen is our here hydrogen is our anode, copper is our cathode. Here zinc is our anode, here hydrogen is our cathode. So that's the way you can understand the cell with respect to cell representation. You can understand the which is acting as a cathode, which is acting as a anode as well. So standard electrode potential means how can you define standard electrode potential? Standard means standard condition. So we measuring the electrode potential of a single electrode with respect to a reference electrode, that is hydrogen electrode, by fixing the standard condition, that is 1 molar concentration of the electrolyte. If gas is involved, we maintain the gas pressure at 1 bar pressure, and temperature we maintain 298 Kelvin. By fixing this condition, if we measure the electrode potential of a single electrode with respect to hydrogen electrode, standard hydrogen electrode, we will call that is a standard electrode potential. Next is electrochemical series. So what is electrochemical series? So electrochemical series means yes, using hydrogen electrode we can measure the electrode potential of different electrode. So if you arrange the electrode potential values of different electrode in the increasing or decreasing order of electrode potential, that we will call electrochemical series. For example, let us arrange in the increasing order. So lithium plus, let us now represent lithium plus bar lithium having a standard electrode potential value E0 cell. Sorry, E0 electrode is found to be minus 3.05 we express in volt. So this is the standard reduction potential value of lithium. I'm not writing every species, I'm just writing the some 2 or 3 one. So this is represent that lithium having the lowest standard reduction potential value, which means it is having a highest tendency to undergo oxidation. That's the way you can compare. Smaller the reduction potential value means no, they having a higher tendency to undergo oxidation. So lithium having the highest oxidation potential, lowest reduction potential, and lithium is the strongest reducing agent because it have a tendency, strongest tendency to undergo oxidation. That's why you can know so many data you can get from the reduction potential value. Then I'm writing the next one, zinc. In between so many metals are there. So zinc, reduction potential of zinc is found to be minus 0.76 volt, which means if you construct a cell between lithium and zinc, understand that zinc undergo reduction and lithium undergo oxidation because oxidation potential of lithium is higher, reduction potential of zinc is higher compared to this, which means higher the reduction potential value for zinc, so this undergo reduction, this undergo oxidation. So that's the way we can compare, and we know the reduction potential value of hydrogen is it is equal to 0. So let me write hydrogen as 0. Then next one, now I'm writing copper 2 plus bar copper, which is found to be 0.34. Then I'm writing the last one, that is fluorine, which is a gas. So fluorine, remember always we measuring the tendency to undergo reduction. So always we writing the tendency to undergo reduction like oxidized to reduced form, because that's the way we comparing. Even though lithium having a tendency to undergo oxidation, for comparison we choosing the reduction tendency. So lower, very negative reduction potential value means they have less tendency to undergo reduction. So look at the value of fluorine. It is the highest we observe. It is plus 2.87. So what does it suggest? Fluorine having highest tendency to undergo reduction, which is indicated by highest value. Highest reduction potential means strongest oxidizing agent. Fluorine is the strongest oxidizing agent because it has the highest tendency to undergo reduction. So fluorine will convert into fluoride ion easily. So that's the way you can compare. So many electrodes are there in between. So if you arrange in a particular order, in the increasing or decreasing order of different electrodes and their standard reduction potential value, if you arrange it in a series, that we will call electrochemical series. Now, what are the uses of electrochemical series? First one, electrochemical series helps to predict the relative ease of oxidation or reduction. For example, choose here. If you compare lithium and zinc, you can understand which is having higher tendency to undergo oxidation. Definitely lithium, because lithium having a lower reduction potential value. So you can compare the ease of oxidation of different metals. That's the first point you can remember. Second point, electrochemical series constitute of any cell setup combining two standard electrodes and make it possible to calculate the standard EMF of the cell. So how can you have the standard EMF of the cell? Now this you can have by choosing two electrode. For example, if I choose between fluorine and zinc, how can you find the EMF of the cell? EMF of a cell now by constructing a cell between zinc and fluorine. It is observed that cathode is fluorine, so 2.87, and anode is zinc, so minus 0.76. So you have to add these two values to have the EMF. So 3.63 volt will be the EMF of this particular cell if you made a cell between zinc and fluorine. So how we measure? Always EMF of the cell have an equation E0 cathode minus E0 anode. So E0 cathode value is 2.87, E0 anode value is minus 0.76. So if you minus it, always remember EMF of the cell will be positive. That's the way you can compare the reduction potential value of two different electrode, and you can find the cell potential of that particular cell as well. Next, now electrochemical series helps to predict the displacement reaction. We know a highly reactive metal have a tendency to displace the lower reactive metal from the solution. So we know zinc when reacted with the copper sulfate gives zinc sulfate plus copper. This is we call displacement reaction. More reactive zinc displaces less reactive metal from the solution to have the corresponding salt. So here look at this. You can understand which metal will displace which metal. That you can understand from the standard reduction potential value. If standard reduction potential value is lower means no, it is more reactive and it will displace the less reactive metal. That's the way you can compare the reactivity. Lower the standard reduction potential value, higher the reactivity of a metal. That's the way you can now predict the displacement reaction as well. That's another important use of electrochemical series. Next, now think about, we know an acid when it react with when a metal react with an acid, hydrogen gas will be released. Now we can have a standard which metal will produce hydrogen gas, that you can understand, because now we know the reduction potential value of hydrogen. Now we arbitrarily fix it is 0. So if the reduction potential value is less than 0, which means hydrogen gas will produce, because hydrogen then definitely H plus ion definitely has to undergo reduction. So if you want to produce hydrogen, H plus ion should convert into hydrogen, which means hydrogen electrode should undergo reduction to get hydrogen, and this has to undergo oxidation. That means lower the reduction, negative reduction potential value. If a metal having negative reduction potential value means definitely hydrogen gas will be released when a metal react with an acid. Now think, copper do not produce hydrogen gas when it react with acid, because copper having a higher reduction potential value compared to hydrogen. So copper undergo reduction means hydrogen has to undergo oxidation, which means hydrogen gas do not produce. So that's the way you can compare the which metal will now produce hydrogen gas. If a metal having a positive reduction potential value, that metal do not produce hydrogen gas, while a metal having a negative reduction potential value, that will definitely produce hydrogen gas when treated with the dilute acids. We can have a calculation related to this. We already done similar like this to find the EMF of the cell. Let's read the question. The E0 value of chromium is given minus 0.76. E0 value of tin is given 0.15. Calculate the potential for the standard cell obtained from these two electrodes. So we have to measure the cell potential. The two electrodes are, one is chromium, another is tin. We know how the cell potential value is E0 cathode minus E0 anode. First you have to choose which will be our cathode. Compare the value. One is minus 0.74, one is plus 0.15. Which is higher value? Plus 0.15 is the higher value, which means they undergo reduction and chromium undergo oxidation. So E0 cell will be 0.15 minus of 0.74. So that will give you the EMF of the cell. If you add it, you will get 0.89 volts. So that is our answer. Now another cell constructed by Fe2 plus, Fe3 plus bar Fe. That's the cell, and Fe3 plus bar Fe2 plus. Still they can act as a cell, because they have a different reduction potential value. So having given these two value, which is having higher value, Fe3 plus bar Fe2 plus having higher value, Fe3 plus bar Fe, which means tendency to undergo reduction from Fe3 plus to Fe. That what Fe3 plus bar Fe is all about. Next one, Fe3 plus to Fe2 plus. So tendency to undergo reduction from Fe3 plus to Fe2 plus. That tendency is higher because suggested by higher value. So E cell will be equal to E0 cathode, that is this time the cathode will be Fe3 plus to Fe2 plus because that is higher value. So 0.771 minus 0.441, which is negative. So just add it, you will get 1.212 volt. So that will be the EMF of this particular cell between a cell Fe2 plus bar Fe and Fe3 plus bar Fe2 plus. So that's the way you can find the cell potential of a particular cell. One should act as an anode, other should act as a cathode. So that's all about for today's class. Thanks for listening. We can listen. We can take class in the. We can meet in the next class. Thank you.